Hi, welcome to Data Structures and Algorithms series by Coding Allies. Coding Allies is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and careers in tech. I'm your host Sue. Today we are solving this Leetcode problem 121 best time to buy and sell stock. So this is the agenda. First, I will go through the problem statement and then thought process for the sliding window approach. I have done two videos for brute force and greedy approach, and I will put the link in the description. So this is the problem. You are given an array prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So in this example here, we have given this array prices 7, 1, 5, 3, 6, 4 and output is 5. So from here we can see that we can buy on day 2 price is 1, and in the future day when we check all the prices, 6 is the highest, so we are going to sell it on that day. So 6 minus 1, the profit we are going to make is 5. So this is the graph, and from here we can see that we could potentially have sold on buy on day 2 and sold on day 3. But if we do that, the profit we will make is only 4. 5 minus 1 is 4. And we can buy on day 3 because there is a dip and then there is a spike, so we can sell it on this day. The value is 6 minus 3, so the profit is 3. But if we buy on day 1, day 2, and then sell it on this day, day 5, and then we are going to maximize our profit. So I encourage you to draw the graph and look at it and think about the approach. And in this video we are going to use the sliding window approach, so now you can start thinking how you could potentially use the sliding window to solve this problem. So let's have a look at example 2. In here we are given these prices and the array, and they are in the descending order. So regardless we buy on this day, all the future days are decreasing, so we are not going to make any profit. It will be negative if we sell it on the following day or any of the day, so the maximum profit is 0. The constraint is the prices store length is between 1 and 10 to the power 5, and the value itself is between 0 and 10 to the power 4. So now I'm going to go through the thought process behind. So in here we can see that this is the visual observation, and which I have gone through. So just visually, with this orange one we can get the profit 4, blue we can get the profit 3, but for the green one, we buy on this day, we sell on this day, the profit is going to be 5. So we are going to use the sliding window technique to solve this problem. Before I go into each steps, first I would like to go through what is the sliding window. Sliding window this technique is used to break down the given problem into simpler sub-problem. And we can solve this problem by breaking down this whole array into or other contiguous data structure into a sub-window or sub-array. So the next item is solve the bigger problem. To solve the bigger problem, we move the window and we find the optimal value. And sliding window technique is used to improve the time and space complexity. If you have solved this problem or watched the video about the brute force approach that we have used to solve this problem, you will understand that why we need to optimize the time complexity for this particular problem. So in sliding window, there are two types. Dynamic variable window. So the window size can change. Window can be shrinking the front. So window, I'm going to call it left and right. Right part can be increasing, left part can be shrinking. like that. So this type of window is the dynamic variable size window. And we also have another window, sliding window type, and that is the size is the same. When we move the window left and right, we are going to move the whole window. The size is exactly the same. So in this problem, we are going to use this dynamic variable size window approach. So let's have a look. So currently we've got this array 715364 from the example 1, and we have got this window, we call it left and right. So we have got this, I have set up these two, so these are the value to keep track. So the first one is sell profit max. So sell is because we are using buy and sell, so I want to use the variable that describe the nature of the process that we are doing. So sell profit max is the maximum profit that we are going to make, so we to keep track, initialize that to 0. And sell profit today, let's say we buy on this day, we sell on any of the day, and we want to check the profit. So to check the profit that we are going to make on that particular day, so to keep track of that, I set up that to 0. So next we have to check. We are going to check prices left and prices compare. We need to compare the value prices left and right. If the prices left is greater than right, then we know that in here it is greater. So we know that we are not going to make any profit. So what we have to do is we have to change the window size. So what I mean by changing is we have to move the left window. We have to shrink this window, move this left to the right, and then we have to increment the right so that we get the next window. So let's have a look. So now we're here 1 and 5. So we do exactly the same. Price, we are going to compare these two, left and right. Of course, 1 is greater than 5. No, it is not. So since it is not, then this could potentially be the day if we sell it, then we are making the highest profit. So we have to check. We check sell profit today. We will subtract prices right minus prices left. So we subtract. When we subtract, the value is 4. So now we've got 4. So which is the current profit, and we have to compare with the max profit. So previously in this step, we have got the max profit, which is 0. In here, we know that the profit is 4, so we are going to compare these two, and then we select the maximum value, which is 4. And then after we finish that, we will increase the size of the window only on the right size, because we know that the stock price could be increasing or it could be decreasing. If it is increasing, then we want to check whether we can get a higher value in the next day. So because of that, we will increase the right size part of the window. So that is what we did in here. We increased the size. So left side, window side left is still here because we are going to compare 3 and 1. 1 is greater than 3. No, it's not. So now this is another day that we could potentially sell and make the maximum profit. So we sell, and the difference is 3 minus 1. It is 2. It's not 3. My apology. So now we are going to compare 2 and 4. Of course, 4 is higher, so our max profit is still 4. And then and then we will increase the right size of the window. So now we check again. Left price is higher than right. No, 1 is greater than 6. It is not. And now this is the day we could potentially make the maximum profit. So we check 6 minus 1 is 5. The previous value for the sell max profit max, previous value is 4. After we increase the window up to here, we have got 5. So now we have to compare this value 4 and 5. Of course, 5 is higher, so now 5 is updated, and we increase the window. So we increase the window. Now we can see, we compare the value again, 1 and 4. 1 is greater than 4. No, we check for the profit that we are going to make on this day. 4 minus 1 is 3. 4 minus 1 is 3, and it should be 3. So 3 and 5, we are comparing these two values. So of course 5 is higher, and then we will try to increase the window to the right, but it is at the end of the array, so we will break out from this loop. So what is the steps? It is not a brute force approach, so that's not it. This should be sliding window. So pretend that this is sliding window, and so we are summarizing what we have gone through. So we first initialize these. So what are these? Sell profit max, to keep track of the maximum profit that we are going to make, and left is for the left side of the window, right is for the right side of the window, so 0 and 1. So while right side is less than the right side of the window is less than the price.length, we are checking for the value, these two value. Prices left, if it is greater than prices right, then we are not going to make any profit. So in that case, then we are going to move the left side of the window to the right, and then we will increment the right. So in here we are using the dynamic window, and then we will update it. So let's have a look at the algorithm. So these are all the variable. The left and right are for the window, sell profit max, sell profit today. So this is for to keep track of the current profit. This is for the max profit. So we check. As long as right is less than the prices.length, we will keep doing it. So inside it, in step 2, we check if the prices in the left indexed is greater than prices at the right. So in that case, then we have to check. We will move the window, left become right, and then we will increment the right. And otherwise, then we are going to make the calculation. The calculation that we are going to make it first, we will calculate the sell profit today, what profit that we are going to make, and then after that we will update the sell profit max, and then after that we have to increment the right side of the window. Let's discuss time and space complexity. Time is O of n. As you see, we passed through this prices array only one time. Space is constant. So I just want to show you the comparison between brute force and the sliding window approach. As you can see here, sliding window approach significantly improved the time complexity from O of n squared to O of n. So in summary, in this video we learned about what sliding window is, what it is, where it is used, and the types of the sliding window. In this video, for this particular problem, we use the dynamic variable window approach to solve this problem, and in this way we reduce the time complexity from O of n squared to O of n. Thanks for watching. Please make sure to subscribe and press the like button if you find this video helpful. Join our weekly Wednesday data structures and algorithm night, where we organize peer-to-peer coding interview. You can find event details on our Facebook page. Thank you.